Welcome back. This next talk is going to be by Jeffrey and Aidan. Aidan lives here in the Bay Area, just over the bridge in Oakland, where they are a bass player who focuses on ska and punk music, and they are also an avid host of tabletop games. Jeffrey is someone I've known for about 5 years, probably the same way most of you do, through his incredible work educating the community on testing in Elixir. This is also probably the first time I've been in the same place as Jeffrey where he's not teaching testing, so I'm really excited to see where he goes with this. Outside of that, I know he's been spending a lot of time in the age-old American pastime of father-daughter bonding using CAD software to design video game cosplays. So ask him about that if you want to learn more. Let's welcome them both to the stage.
Hey, thanks so much for coming out. We're talking about crafting fully custom code generators to speed up your development, help encourage consistent patterns across your teams, and hopefully codify some of your design decisions on your Elixir applications. We're all probably familiar with Phoenix and Necto's out-of-the-box generators, and they're really great. They get you pretty far, a beautiful jump start. However, if you've ever tried to customize them for your own projects, you might have run into some friction. We definitely have. We're going to tell you a little bit about that and what we've learned. As mentioned, I'm Aidan. I'll throw in there, I also love to tinker with electronics. I'm real excited about all the IoT talks that are here today. If you want to talk about that kind of stuff too, I'd love to. And I love making tools that bring developers joy. Hopefully these generators bring you some joy.
And I'm Jeffrey, and I like to make things with power tools, 3D printing, and CNC machines. And as a bunch of you probably know, I also co-authored Testing Elixir. Today our goal is to demystify custom code generation. We'll go through the process of writing your own generators, we'll do a demo, we'll share some of the techniques that we have done, we'll talk about some of the motivations about why we got here in the first place. We'll do a very brief and not risky at all live demo. And our goal is for you to walk out of here completely unimpressed. We want you to be like, oh, that's simple, perfect. And if you leave here actually thinking about how you're going to apply it to what you're doing, we'll be even happier. So we think we're going to have time at the end for questions. Be thinking of them as we go.
We both work together at a company called Mechanical Orchard, which is where we started playing with this idea, and Jeffrey has continued to shepherd it on and develop it. At Mechanical Orchard, we take on legacy code bases. We modernize them safely and carefully into modern languages. Often these are code bases written in COBOL, 20, 30 years old, maybe even more, and replace them with often Elixir. So we had a pretty big challenge in front of us. We had a short time frame with a client. We had to generate a large amount of code. This was luckily all had very similar patterns to it that we could identify. And we found a lot of traction using the Phoenix and Necto generators at first. However, we continued to find that we had more information. We had the original source code. And we also had access to the database, so we had all the database schema. So what would be great if we could just point a thing at this and generate our schema, generate our factories. So we wanted more control over the outputs that we didn't necessarily have. We wanted more complex data inputs into the generators than we were getting through the command line. And we also needed to support this older version of Oracle because we needed to keep talking to their existing database. And that had some different design decisions than what you'll usually see with a Postgres kind of setup.
So it's very likely that you've heard the phrase, Phoenix is not your app. Phoenix is awesome, and one of the reasons we like it is we can leverage all the things that it brings to us, but we can absolutely design our file application structure to match whatever our real project is, unlike a lot of other frameworks, at least that I've worked in. And we love that, but the catch is that your code generation should also match your needs and not be defined by what Phoenix does. So we're super appreciative of the work, especially because it's kind of gave us our head start or gave us a direction to start with for the work that the Phoenix team has done building their generation. But the fact is, and they provide customizable templates. So if you're building an app and you just want to be able to change up what your tests look like, that's all doable. If you want to change up, your styling on your stuff, that's already doable by just using a customized template. But again, we're talking about things like file structure. The Phoenix generators were written based off of what the Phoenix team could predict. And they can only predict so much for every project out there. And on top of that, they only work for a Phoenix application. And sometimes you're working in Elixir code that's not Phoenix. So for our project, we actually had 3 different sources of truth that we were working with. The first one is we had the source code itself. And it was pretty nice. It was created by a code generator in around 2000 on this particular project. And it gave us some consistent patterns, and we were able to write a custom parser to help us distill what we needed from that application. We also, as Aidan mentioned, we had an Oracle database that we were working against. We wrote a task that would actually query against the tables that the parser told us that we were hitting. We would get all the information from the database about that, and then we also had humans who were using this old legacy app. And despite the fact that we needed to replicate the same functionality, there were basic needs, especially just as upgrading into a modern web app, that we wanted to know what we could improve for their situation. And all that, we then managed to put it, coalesce using software, like just a script we wrote, we called the digester. We aggregated all those sources of information and wrote a generator input file. And so that was specific to this project. Everything that we would do that we're recommending today starts with that generator config, or that generator input file. One of the things that we ended up doing is we started with the Phoenix generators and worked backwards. So we were like, oh, they know what they're doing. It's wildly complex. They're doing a lot of things, and they're solving for a ton of cases that weren't relevant to us because we knew what we wanted. And they're written to be very flexible, despite the mention of the kind of rigid file structure. So after we got through this first trial on this project, we were like, you know what? If we were to do this again, we think we'd start from scratch, from the ground up. This actually, like, going that approach made it way more complex and meant we had to load a lot more context than we really needed. So the catch is that I've done this a couple more times since we worked on this first project, and it's true, like, ground up is just way easier. So because we can't share customer code with you, we have written a sample project. I'm going to tell you right now, this QR code will stay up through the rest of the presentation, but we'd love for you to grab it. This is available as a reference for any time if you walk out of here and be like, what did they do again? This application does have a working, running generator in there. We're going to do a demo of that, but instead of walking through all the generated code, because you have this as a reference, and honestly, aside from the fact that it has like a non-standard Phoenix file structure, there's nothing wildly surprising about that code itself. We're going to focus instead on how we built the generators, and we'll go from there. So as I mentioned, this QR code will stay up if you didn't get it already. And the app itself is called Arcane Assist. We built the very beginning of a role-playing game master tool. And it is currently tracking NPCs, or non-player characters. We're going to run a generator that then adds in functionality for tracking quests and their milestones.
Yes, as Jeffrey mentioned, we've got our existing code base here that has just NPCs, and we've got a couple of tests here. So if I run our tests, you can see we've got 15 tests. That's pretty great. We've got one context. It's not too complex yet. But then we have our generator. And if the ZSH code expansion, there we go. As you can see, we call our mixed task gen.resource. You could really call this whatever you want. We were kind of working with the idea that each of our inputs would be a resource. And we have this generator inputs called quest.ex. We're going to go through all of these parts a little bit more in depth in the slides in a little bit, so don't stress too much. This is a lot of information at once. But this is kind of the way we run our generator. I'm going to run it here, and you're going to see it's going to give me a lot of output. So at first, you can see it's told me all the files it's made. So it's told me the migrations. It's told me the schemas it's made for those. The core file here is so you can access those schemas. So you can list things, get things, schema access you're probably pretty familiar with. I'll take an aside. As Jeffrey mentioned, we chose a non-standard kind of project layout, something that's different from what Phoenix or Ecto will generate, partially to emphasize, like, you have total control if you're doing this yourself. You don't have to play. You can do what your team thinks is the best thing to do, what your architectural guidelines say, what have you, and get a lot of flexibility. You can see we've also generated tests in the live view. And this bit here at the end, we haven't actually wired up the bits where it will inject our test factories. So the lazy thing, the easy thing, we recommend doing this in little slices and doing the easy things, is just to put it out into our console and say, hey, you've got these factories, go ahead and add them to your factory file. And so if I do that here, and if you're using something fancy like Styler, it'll move your aliases around. I'm not going to worry about it for the demo. But I am able to rerun our tests, and now we've got twice as many passing tests.
More
twice
tests,
as many files.
better.
More tests is always better. Jeffrey will definitely argue that. But that's it.
So a generator, as we said, we wanted to demystify this. It's a really simple concept. It's just an Elixir module that gets some sort of input, whether it's from the command line like the Phoenix generators, or we use a file, and it invents some code and it writes it into a file. Mixed task is perfect for this, so we didn't stray from that. And we, as you probably saw by the file extension of what we passed in the demo, we actually keep our inputs as Elixir files.
We could truthfully parse whatever we want. You could keep these inputs as JSON or YAML. You could directly connect to your database. You could connect to Run APIs. This is programmable. You can do whatever you want to do. But we found it much more preferable to decouple that kind of data gathering from the file generation itself. In that step we mentioned earlier, the digester. So it can digest all of these different inputs, assemble that into input files for the generator. This also gives us a little bit of a break in that process where we can human audit the thing, and we can say, all right, did the digester gather the information? Does it look like what we want it to look like? And you can also make these input files by hand, like we have for this demo. None of this was auto-generated.
And that's actually what my current project, we're handwriting them all after we do a bunch of research on the thing that we're replacing.
Exactly, yeah. So in our current example, you can see some things in here. The schema is at the bottom of this file because it's all alphabetical, so it falls off the page here. But you do have the context in the live view, and you can see we've annotated with a lot of metadata, like what are the actions you can take and what have you. And all of that will be things that we can act upon in the generator to make decisions about what to generate or what kind of data to show.
So one other callback on, or call out real fast on the one we just showed you is that we used a keyword list. That's ultimately what you pass in when you're evaluating an EEX template. So our input files, played around with keyword lists. I've got another one where it's structs, and then we have to just move it to a keyword list. Again, it's code. You know how to work in Elixir. So our templates themselves are probably going to be familiar to anybody who's worked in a Phoenix project. They are EEX. And for most things, you can get away with just doing a simple, straightforward interpolation. You'll notice that each of the keys from our keyword list are available as a variable in the EEX template. We'll show you how this all gets lined up in a few minutes. But there were times, though, where we had way more complex things. And I'll be honest with you, I kind of suck at working in EEX when it's a complex thing and like if there's any sort of branching logic. And so with that, we have a different approach. And you can see that we're actually leveraging a variable here called helper. And then we're calling a function on that, and we're passing in fields from that. And so that leads us
to our third component, the helper module. We'll see a little bit how that actually gets wired in and how it's made available. But this is really useful to help us kind of keep some of that logic out of the EEX. As Jeffrey said, it's really difficult to do certain things in EEX. It's going to look very messy. It's going to be hard for you to read and comprehend, and especially if you're picking up the project or the generator to get up to speed with it. And it helps keep that logic reusable. So if you need to define your fields, you're able to reuse those functions a lot more than if you're trying to do everything in line. So for example, our helper to build up the schema that we created, you've got where we are able to derive the name from our fields, where you can pass to a function for ectotype, and it's able to use pattern matching to determine what type of thing to return here. And in our case, whether or not it's a default and what that value might be if we want to concatenate onto there. Doing all of this in EEX would be pretty not ergonomic and pretty frustrating. We've done it and then moved to extract it all out for good reasons. Here you can see another good example, such as generating factories. So we're able to kind of map over all these fields in a similar way. You might want to pull out all the options so that you're able to make sure you're generating valid data based on what you said those things can be. And of course, you can always set up a thing so that if you introduce a new type that you've never seen before, you throw an error, and then the generator never finishes. The generator never writes those files, and you get fast feedback, and you can improve your generator.
So pulling all those things together is the mix task that we mentioned earlier. We've got a really basic pattern that we start with, and again, like, hey, it's a starting point, but you can figure out what works for you. So for us, the first thing we do inside the mix task is we get that file input. You'll notice we are taking a single thing because we found it way easier to take a file and do that, and we're evaluating it as Elixir. So that's what the code.eval file is there, and that's how we can keep an Elixir structure in the input file itself. And we just found that way easier than trying to design a command line interface, especially because the only people that this is serving is us, right? We're not trying to write a DSL for anybody else. And then here's the line where we add in that helper module to the things that we parsed out of that file. So it's aliased here up above in this code. And then we run we've got different, for each step, we've got generator functions, and we just map through, or we just run through and call each of those, hand over that same set of inputs, let them grab what they want from it. The one catch is that every one of these functions needs to return the file names of the files that they created, and then we run mix format on a flattened list of the files, and that way we don't have to spend nearly as much time. We originally spent way too much time trying to line things up and make them look right, and at some point we were like, wait, there's a tool for this. It's embarrassing how long we spent working on this before we realized we could just cheat. The one other note is that the last function here, the output factory functions, that's the one that just printed to the screen. So we use the helper file to generate that too, because it's just string manipulation. And then we just did an IO puts on the output from that, and then just made sure it returned an empty list so that there was nothing for it to try and format. Generation function itself, like this is a pattern you saw, we've got a bunch that we call. They're straightforward as well. They have an EEX template that they read. They then call EEX eval string. This is like hidden under the hood of what Phoenix is doing with their generators, but this is the magic. There you go. This is the thing. We just sold out our own project, our own talk. This is it. This is the whole magic line. So you evaluate that, passing in the params from your input, and then you just have to come up with, that's sitting in memory, right? Your whole file is sitting in memory. You just got to come up with whatever the right module name is, or I'm sorry, the right file name is for it. And then you run mix generator create file. That force true will just keep overwriting it. We use that a lot for doing a fast rewrite loop. And then at some point when you start thinking that like, hey, maybe this is stable, or you start actually using it in your project, you might want to flip that over so it just asks you to confirm before it overwrites a file. And then the last thing on it is that you've just got to make sure you return the file name. And again, because we're using that flatten on the list that we handed back to mix format, if you're making more than one file, you just hand back a list of those file names.
Yeah. I mean, doing all of this a couple of times now, we've come up with a few patterns and like things to keep in mind to help us make sure we're making generators that are easy to maintain, easy to use, easy to write. So first of all is to validate your patterns. Make sure you know what you want it to generate. It's going to be a little harder to retool them later. So start small. Take a thin slice of something you know, like a schema, that is going to be relatively stable, or you know what you want it to look like. One that's maybe less obvious is to avoid generating in your compile path. So something we ran into a couple of times is generating code that doesn't compile into your compile path will prevent you from being able to run your mixed task generator because your code doesn't compile. So we often will start off kind of generating into a temp directory for a couple iterations until we've hit something that's pretty stable. It slows you down a little bit needing to remove those files. It's a bit of a hassle. Similarly, make sure you're running your generators early and often, and the tests that you're generating too. You don't want to find out after a day of work that something is broken. You want to find out after 10 minutes that something is broken so you can fix it early before it's more complicated to dig it out. And similarly, kind of starting from that golden example, some of these templates, we wrote a good golden example and then the MPC and then replaced all of the references so that it would print the same thing that the NPC was, just with Quest, wherever it was, or with the fields from Quest, wherever it was. As we've mentioned as well, using those complex input files like EX files or other data sources really helps, because trying to do something through the command line or trying to do something that's a little too naive in its structure is just going to limit your ability to pass configuration and pass data. As Jeffrey mentioned as well, we spent a little too long before we figured out about the formatter. Use the formatter. If you're using styler, that might even be better for you if that's what's in your code base, because it will do that kind of moving the aliases around and reordering things for you. It'll save you a lot of pain. And finally, the use strings where possible. In certain cases, if you're like inspecting a module name or whatever, it will add on certain bits of data that you might not want. There's little surprising things here and there when you're not using strings, or if you're trying to put a list in somewhere without doing an inspect, you might be like unpleasantly surprised about what you come out with. It's a lot easier just to stick with string template and just string interpolation.
Yep. So just some things to remember. You're not writing a library. You're not doing this for somebody else. You are doing this just for yourself or your team. And there's a couple things that come with that. First off, a second note, if you are writing a library and you're trying to write generation, like at that level, like look into Igniter. I think Zach's talking about it later in this conference, and it's a really neat tool to like step it up. But the whole point is, you don't have to solve all of the future problems. Solve for what you need now, and then as you continue to use the generator, make updates to it. Generate, and on that note, generate case by case. Use it, update your code or fix your code so it matches your situation, and go to the next one. We got into a situation where we generated all of the things. We got very excited, and we're like, and then suddenly we were in a world where like the time between when we generated and when we were actually making the small little fixes was spread enough apart that it wasn't great. And then multiple small generators are just as good as one thing that does a bunch. So like we demoed something that actually built out a stack of files, but like any single one of those functionalities would have saved us time in a project, right? And so start small. And then you don't even necessarily have to keep making it bigger. Like just maybe call 4 different generators, and that's fine too, and it keeps the size of the project or the problem smaller for you. The second last thing is generated code doesn't actually have to work. It just has to save you time, right? And so this is one of the big places where it's different from taking the time to build out an abstraction. Hey, we keep doing the same thing. Now I want to pull it out into a place where we make it work for all these other places, but it has to work. Whereas generated code actually doesn't technically have to work. You can get it 80% of the way there, and then you fix it, and you're in a good place. That said, it's not intended to be a replacement for abstraction either. You write your abstractions where you can make that thing, where you do have the rules, where you can make it work for all your scenarios. Awesome, that's a great way to go. And then you generate code that calls your abstraction, and you've still saved yourself that time.
Yeah, so kind of what's next? What have we been looking at with generators as we continue to play around with this concept on new projects? Structs and validations have been really great on the input, trying to see if we can kind of help nudge people towards the right data that's being input into these things. Not everyone needs to be an expert on how the generator works internally, but it helps if we can help them use it correctly. Injecting code into pre-existing files. So you saw me copy those factory files in. On some projects, we've had here or there some success with injecting routes into the router or injecting the factory functions directly into the factory. So the user doesn't have to think at all. It's just done for you. And we've played around a bit on the project with isolating some custom logic. So there might be, okay, that 80% Jeffrey's talking about. Well, can we just put hooks in that call out, and then you're able to write your custom logic in a place that's not at risk of being regenerated, and then you can regenerate this file that you're generating forever, because you don't have to worry about overwriting that file. It's always going to do the right thing and call that custom logic every time. And for our purposes, we've been exploring things like AI to help write our inputs files from source, source manipulation tools like Sorcerer, and of course, we'd love to hear whatever you've got cooking in your minds after this as well.
So we want to throw out a big thanks to Mechanical Orchard for giving us the time to figure out all these patterns and play with this stuff. Thanks to John Ryan and the Vintro and Sankey teams that we work with for their efforts and support on all this as well. And thanks for Codebeam America for us being here. This has been great. We actually did what's kind of unheard of in conference talks. We have somehow managed to go longer and not talk faster, so we actually are out of time. We would be more than happy to take questions in the hallway or wherever you can grab us, but we're at the end of our slot. So thank you all very much.